Okay, today we're going to be talking about section 11-6, and we're going to be adding and subtracting rational expressions with like denominators. They're going to have the same denominators. Okay, so we're going to recall that when we added 7/10 to 1/10, as long as you had the same denominator, you can carry over that denominator and you can just add the numerators. Okay, for this problem you'd have 8/10, which reduces to 4/5. Okay, and the same was the case if you were subtracting. Say you were subtracting this value. You take a look at the denominators. They're both the same, so you're going to carry that over into your answer, and you're only going to operate on the numerator. Okay, so this will yield 9/10. Okay, so the general rule is if the denominators are the same, you add or subtract the numerators and keep the same denominators. Okay, so we want to write this out. And that's the same whether you're working with rational numbers or rational expressions. So the denominator may be a monomial, a binomial, a trinomial, or any type of polynomial. Okay? So we're going to start with one example to help illustrate this point. Okay? First example, 5 divided by 3xy plus 2 divided by 3xy. Okay, we're going to apply that rule. Same denominator. We'll have the same denominator in our answer. Okay, so we're going to add the numerators, 5x plus 2x. Okay, well, what do we get there? That's going to be a total of 7x over 3xy. Okay, each one of these is a factor, so it's 7 times x really that you're looking at, 3 times x times y that you're looking at, so we can cancel out any common terms in the numerator and the denominator. Okay, so 7 over 3y. Cancel out any common factors. Okay, all right. Let's take a look at example number 2. In example number 2, you have the same denominator again, but these are binomials, but it really doesn't matter. Okay, you're still going to carry that over into your sum, and you're only going to be operating on your numerator. Okay, do you notice whether or not we can factor this even more? You might have noticed that there is a GCF in that numerator. That GCF is 13, and if you factor that out, you may have gotten this value. Okay, and do you notice anything else now? That's right, we have a c plus 2, a binomial, in the numerator and denominator that match, so you can cancel those, leaving you with the simplified answer of 13. Okay, so far so good with addition. Okay, I'd like now to switch to an example that incorporates subtraction, because subtraction is a little bit different. Okay, it is the same in the case where denominators are the same, so you carry that over. Okay, however, there's one important note to make when you are subtracting, and that has to do with the sign. What you have to do with the sign, and what I encourage you to do, is actually to put all your binomials in parentheses, because that will really accentuate the sign. It will remind you that you need to distribute that sign. Okay, so write a note to yourself, and when subtracting, remember to distribute the minus sign. Okay. Great. Okay, so we're going to distribute our minus sign, subtraction sign, and we will get 3x plus 4 minus x plus 1. Okay. Simplifying this, 3x, I'm going to take away an x, so I'll have 2x left. 4 plus 1 will give us 5, and x minus 2 in our denominator. Okay, we can't simplify this anymore, so this is our answer. Okay. We're going to talk about the case where you might have something called an inverse denominator. And an inverse denominator is a denominator that almost looks exactly the same, but it's not exactly the same yet. What we can do is kind of work with it a little bit. Let's see what happens if we switch the terms. Okay, we're going to switch the order using the commutative property of addition. Okay, we're getting a little bit closer. We got the order right. We got m and then 2, but the signs are opposite. So what we can do now is factor out a -1. And what do you know? Okay, what you have here is 3m over m minus 2 minus, and this is a 6 over a -1, that's a -6, so the entire fraction is a negative. 6 over m minus 2. Okay, good thing is our denominators match now, so we can carry that over. And we remember from the very last example that whenever we're subtracting, we have to distribute that negative. So it becomes 3m plus 6. Okay. So even if we factor out a GCF, I don't believe that anything else will cancel out. So we're done. Okay. So the very last thing, let me show you that. The very last example that I want to touch on is a word problem, because you will encounter word problems in your homework assignment. Okay, so the word problem goes, find the width of the rectangle if the perimeter is that polynomial and the length is that polynomial. Okay, all right, so we're going to start with drawing our rectangle. Okay, labeling the length. So far so good. And we know that the perimeter formula from our previous experience is 2L plus 2W. What I'm going to do first is I'm going to manipulate this, because we know our P, our perimeter, that's given. We know our L, that's also given. So what we're really doing here is we're solving for W. Okay, W here we're going to say is the width. So let's write our let statement. Let W equal the width of the rectangle. Okay, so we're going to take our formula and we're going to see what we need to do to find our width. We would first subtract 2L. So we have P minus 2L is equal to 2W. And I'm going to multiply by the inverse, which is 1/2. Okay, so I'm going to clean this up a little bit. W is equal to 1/2 times P minus 2L. Okay, so this is what we need to do to find our W. Okay, so word problems like this are quite lengthy and they can get kind of messy. So what I always like to do is I like to write the steps out of what I need to do. Okay, so step number 1, I want to find my 2L. Find out what 2L is. Okay, step number 2, I'm going to take my perimeter and I'm going to subtract my 2L. Okay, and the very last step, I'm going to take 1/2 of that value. Okay, so when you take it out in pieces, you break it out into pieces, it's a little bit more manageable. Okay, all right, so let's start with the very first step, finding 2L. So number 1, we're going to find 2L. Okay, we know that our length is 5x plus 4y over 2x plus y. So we can multiply those two together. Okay, so multiplying together, you know you need to distribute. So 10x plus 8y will be over 2x plus y will be our 2L. Okay, so put this in a box. Okay, we're going to move on to step number 2. Is we're going to start with our perimeter and we're going to subtract our 2L. Okay, so our perimeter was 4 times 4x plus 3y all over 2x plus y. We're going to subtract, and remember parentheses, 10x plus 8y all over 2x plus y. Okay, we have a common denominator, so that's really good. Okay, let's simplify this a little bit. Do you notice things that we will need to distribute? Okay, we'll need to distribute the 4. We'll also need to distribute that negative sign, or that minus sign. Okay, so we will get 16x plus 12y all over 2x plus y. And actually, this is going to be all over 2x plus y, so I'm going to extend that line out. Okay, and I will have minus 10x minus 8y. Okay, I can simplify this some more. That will be equal to 16 minus 10 is 6x, and 12y minus 8y plus 4y all over 2x plus y. Okay, what we solved here was p minus 2l. The very last step we need to take is to take this number and multiply it by 1/2. Okay, let's get a fresh sheet of paper. Number 3, we're going to take 1/2 of the p minus 2l. Okay, so you're going to have 1/2 times, let's see here, 6x plus 4y all over 2x plus y. Okay, well, we know from previous videos that when we are multiplying, what we're really doing is just extending this out. Okay, so 1 times any number is just that number, so 6x plus 4y all over 2 times, in parentheses, 2x plus y. Okay, we can factor out a GCF here. Okay, looks like there's a GCF of 2. So we have 2 times 3x plus 2y all over 2 times 2x plus y. Okay, common factors that on the top and the bottom, so we can cross those out, and your width will be equal to 3x plus 2y all over 2x plus y. Okay, we have solved for our width. Of course, it's a word problem, so the width of the rectangle is 3x plus 2y all over 2x plus y. Okay, so it's a really long word problem, I'll admit that, but if you plan things out step by step, it really isn't as overwhelming as you think. Okay, so your problems for tonight that I'd like for you to do are these problems right here. There are 3 of them, and bring them back tomorrow and we will talk about them. Thank you.